Hey folks, and welcome to the latest video in the Rhapsody Power Pack series. I'm Andy Lapping, and in this video I'll show you how to improve the Rhapsody CSV importer to create dependencies. The Rhapsody CSV importer is a really useful capability, but it does have its limitations. The Power Pack provides powerful post-processors that extend that basic import capability Rhapsody provides. In today's video, we're going to look at dependencies. First, let's take a look at the basic import capability. Here in this simple CSV file, I have two columns. I want to use this CSV to create dependencies from the model elements in the first column, let's imagine those are constraints, to the model elements in the second. This CSV importer does just that. On the Criteria tab, the element type has been set to constraint. On the Columns tab, I have two columns. The first is the name of the constraint, and the second creates a dependency. If I open the CSV import settings, I've already set the importer to import the CSV file we just saw, and the data will be imported into the constraints package. That constraints package is currently empty, except for this break block. So let's run the import. Now our constraints package has some new constraints and they have dependencies. Now, by the way, did you know that CSV importers are new terms based on table layout? That means I can right-click the importer and create a table from it, which is pretty cool. Now, on the face of it, all of this looks okay, but there are several issues. First, what if I wanted a stereotyped dependency like a trace, or a new term like a satisfy? The CSV importer provides no facility for that. Only basic dependencies can be created. What if I wanted the dependencies to be created in the other direction? That is, to the imported element, not from it. Well, that's also impossible in the basic importer. Secondly, these dependencies point at the first model element Rhapsody finds with that name. It doesn't care what the type of that element is or where it's located. For example, this dependency points at this break block, but only because it's in the same package as the column elements, so it's found first. There's another break block here in the architecture package. What if I wanted the dependency to point to that? Also in this package is a motor block, and there's another motor block in a sub-package. Well, this dependency doesn't point to either of them. Instead, it points at the first element found with that name. In this case, that's a dependency it created as part of the import. Okay, let's delete all of those constraints and start again. First, I'll add a post processor to the importer, which you will find on this menu. Power Pack, add CSV importer post processor, and in this case, we're going to do dependency. Now, if I expand the tree, we have a CSV post processor called dependency. Now, the CSV post processor is a new term based on tag. Now, that will become important in a moment. The CSV post processor has several tags that let me control that post processing. The incoming tag lets me create a dependency in either direction. The find tags let me filter the types of element for the dependency source or target. And finally, the apply stereo tag lets me do just that, apply a stereotype to the dependency. And that can either be a new term or a basic stereotype. Let's use the model element editor to supply some values for those tags. Now, find meta class is a comma-separated list of base terms or new terms. Let's use block or actor. Now, I could also use the find stereotype to apply more filtering, but let's skip that one for now. I will, however, use apply stereotype to apply, let's say, the trace stereotype to the imported dependencies. Now we've configured the post processor, how do we use it? Well, simple. Let's open the features for the importer, and on the Columns tab, I'll replace the existing Depends On column with a tag column. And in the property field, I'll select the dependency CSV post processor. That's it. Let's now run the import in the usual way. Now we have some new constraints, and those have trace dependencies to all of the elements that pass the filter criteria, for example, both motor blocks. Now, instead of referring to the elements by name, you can use full paths to be specific. For example, here in this CSV file, the first row, C1, specifies the model element by full path rather than simply by name. Now, the post-processor also supports comma-separated lists, so you don't need multiple rows for the same source or target element. Let's delete those constraints again. And let's open the import settings for our CSV importer, and we'll change it to point at the CSV file we just saw. Then we can run an import. Now, C1 only has one trace dependency, and it's to the block specified by full path in that CSV file. One last thing, let's import dependencies in the opposite direction. Here in the requirements package, we have some requirements, and here in the actors package, we have several actors, A1, A2, A3, and a comment, also called A3. Here in this CSV file, the requirements are in the first column, and the elements we want to create dependencies from are in the second. I've already set up a CSV importer with a criteria of requirement and two columns just as we did earlier. And I've also added a CSV post-processor to create my dependencies. This time, incoming satisfy dependencies from actors, but only if they have a stereotype of active. Let's run that importer. Now the active actors A1 and A3 have satisfied dependencies to the requirements. Well, that's it for this video. Over the course of the series, we'll explore the rest of the Rhapsody Power Pack features that will greatly improve your Rhapsody user experience. So please do subscribe if you want to be notified as those videos get published. But for now, thanks for watching.